Okay, we're going to start the review process for Chapter 2 tests over inequalities, solving simple inequalities, solving compound inequalities. And I'm going to start with a couple of simple reviews. If you're actually in my class, then this is on page 80, 81, and 82. This is number 7 from the review. So the directions say to solve the inequality, then graph the solution. This is a simple inequality, just a one-step inequality. We solve this just like we're solving an equation. So I have 4 being subtracted from r, so I do the opposite. I add 4 to each side of the inequality symbol. This cancels, bring the rest down. R is less than -2 is the solution. And now I graph using a number line. I'm talking about the number -2. I have an open circle because of the fact if you have a less than or a greater than, it's an open circle on your graph. If you have less than or equal to, greater than or equal to, it's a shaded circle on your graph. So I have just a less than. When the variable is written on the left, r is less than -2, then the arrow in your graph will point the same way your inequality symbol is pointing. So my graph will point to the left the same way that my inequality symbol is pointing to the left. They match. If in the future, if your variable is on the right hand side, your graph will point the opposite direction your inequality symbol is pointing. Let's continue on with another example. This will be number 8 on the same page. So like number 7, this is a one-step inequality. 6.7 is being subtracted from m, so I do the opposite. I add 6.7 to each side. And if you have a calculator, you can do that calculation. These cancel. Since my decimals are lined up, it's pretty easy addition. 8.8. Bring the rest down. And I have m, if I'm reading from the variable, m is less than 8.8. It may help you if you rewrite the inequality such that or so that the variable is on the left. This way, first of all, this reads the same thing. M is less than or equal to 8.8. M is less than or equal to 8.8. But if I look at it from this viewpoint, now when I graph, I'm talking about the number 8.8. I have a shaded circle this time because it has an or equal to. And since my variable is on the left, the arrow in my graph points the same way my inequality symbol points, to the left. Okay, the next example is going to be number 11. So I have -3/4 times n is less than or equal to 3. So since the fraction is right next to the variable, that indicates multiplication. So to get n by itself, I have to do the opposite of multiplication, which is division. I'm going to simply divide by -3/4. These will cancel, become 1. Since I'm dividing by a negative, my inequality symbol flips. And if I divide the left side by -3/4, I have to divide the right side by -3/4. Now, you have a calculator that you can do the calculation as 3 divided by -3/4, and that will give you the answer. But if we were doing this by hand, we would have to put this over 1, and then we would use keep, switch, flip. Again, this is only if you're doing the fractions by hand, which means I keep the first fraction, I switch the sign to multiplication, I flip the last fraction, and then I multiply top times top, bottom times bottom. 3 times 4 is 12. 1 times 3 is 3, and there it's negative because a positive times a negative is a negative, and that becomes -4. Again, n is greater than or equal to -4. You could have simply used your TI-84 calculator to plug that in, and that would have given you -4 as well. That's probably your easier option. Quick sketch of the graph. Talking about the number -4. Have a shaded circle because of the or equal to. My variable's on the left. My arrow must point the same direction my inequality symbol points. It points to the right. N is greater than or equal to -4. This will be number 12. So here I have S being divided by -8. Well, I undo division with multiplication since it's the opposite. So I want to multiply both sides by -8. These become 1, or they cancel. So S is, since I'm multiplying by a negative number, I flip the inequality symbol, and 11 times -8 is -88, and that's my answer. Quick sketch of the graph. -88. Filled in circle to the left because the variable is on the left. My inequality symbol points to the left. Should be getting simpler by the minute. Let's look at an example that's a little bit more difficult. This will be number 18 from the review. And I just replaced the variable s with the variable x. So my first step here is to distribute, but I'm still solving the same way. Solving inequalities is just like solving an equation, except for on the last step. If I have to multiply or divide by a negative number, I must flip the inequality symbol. So here I would just distribute first like I would normally, even if I were just solving an equation. 2 times -4x is -8x. 2 times 2 is +4, and I'll bring the rest down. Now, since I have variables on both sides of the inequality symbol and constants on both sides of the inequality symbol, I get to choose which side I want the variable on. What I usually do is take the smallest variable and move that. So -8x is the smallest, so I will add 8x to both sides. This will ensure that my variables are positive. These cancel, bring the rest down. Add 10 to each side. These cancel, become 0. Bring the rest down. Notice how I'm showing every step. You do not want to skip any steps. That is a 14. So now I have 3 as being multiplied with x. So to get x by itself, I must divide by 3. On both sides, I divide by 3. This becomes 1, or just 1x, less than or equal to. And 14/3 is an appropriate answer. If you want to turn that into a decimal, that could also be 4.66 repeating. Or I could turn it into a mixed number, and that would be 4 2/3. Any of these 3 numbers will work depending on the directions or instructions you're given. So a quick sketch of the graph. I'll use 14/3 as the number. I have a closed circle or filled in circle because of the or equal to. Now notice here that my variable is on the right hand side. I could choose to rewrite it with the variable on the left. That's probably the easiest way to do it. X is less than or equal to 14/3. Notice this is the same thing as this, written from the other direction, with x being on the left. So my variable's on the left. The arrow in my graph must point to the left since my inequality is pointing to the left. X is less than or equal to 14/3. We'll now look at number 20 from the review. So this one is a lot like the previous example where my first step is distribution. Distribute the 3. 3 times r is 3r. 3 times a minus 6 is minus 18. Bring the rest down. Oops. Let me erase this real quick. You're probably confused why I have an r and an x. This should be r. Okay, so you're probably thinking, if you've been working these problems, something is unique about this problem because the variables are the same on both sides, and there is something unique about this problem. We'll continue, and I'll just say let's move the variables to the right-hand side of the inequality. So I'll subtract 3r since they're being added over here because it's positive. Then I subtract 3r from here, and both sides, the variables cancel, and I bring what's left down, and I look at what I have left, and I have to determine whether or not this is a true statement. Is negative 8 greater than negative 18? And some may struggle with this, but if you think about a number line where you have 0 here and then 1 here to the right, well, if you go further to the left, you'll have negative 8, and then further on down, you'll have negative 18. So negative 8 is larger than negative 18. So this is a true statement. Therefore, it is infinite solutions, also known as all real numbers. In other words, any number on the number line. If I plug in any number from the number line for r in the original inequality, I will have a true statement. The answer is infinite solutions. The entire number line. And my last example will be number 25 from the review. So here we have a compound inequality, and it is an OR inequality, or an OR statement, because I'm given the word OR up here. When you have an OR statement, your graph is going to have two numbers, and it's going to look something like this. Now you may have a shaded circle or unshaded, but there will be a separation in the middle. If we ever have an AND inequality, remember that that is going to be a graph where it looks like a barbell. So if you know those things in advance, you kind of know what you're looking for in case you make a mistake and your graph doesn't look like what you know it should. So I'll solve these two separately. So I have r being divided by 4, so I multiply by 4. Do the opposite to each side, times 4. This cancels. I get r is less than negative 20. Then I'll come to this side and solve. I'll add 7 to each side. Cancels, bring the rest down. Divide by negative 2. Cancels. I'm dividing by negative, so I'll flip my inequality. R is greater than or equal to negative 5. Okay, so I have this or this is my answer. Looking on the graph, on the number line, the smallest number is negative 20. I'll put that to the left. Make sure you, when you're actually making these graphs, if you have to make your own, make sure that the number line is appropriate with the smallest number to the left, the largest to the right. Above the negative 20, I have an open circle because there's no or equal to. Above the negative 5, I have a shaded circle because of the or equal to. Variables on the left over here, my arrow must point in my graph to the left, away from the negative 20. And over here with the negative 5, variables on the left, my arrow must point to the right because the inequality symbol points to the right, and that's the way that works.